some of the ALEKS Chapter 1 topics. So this is in student view. So I have all the topics passed off so that I can answer questions with you. So I'm going to go to this hamburger and I'm going to go to review because I have all the topics in review. You might still have some in learn, but this is a good way. So once your topics are learned, you can get to them through review and you can review for them for the tests. So that's nice. Assignments you need to work on. We can look at that really quick. So there's going to be a spot if you haven't finished something, it'll show up in assignments. And then gradebook, once the due date has happened, then your grade is permanent. So even if you have 100% and then there's a knowledge check, if you lose some of the topics in the knowledge check, your assignment, the gradebook doesn't change. You might have to go back and review some of the Chapter 1 assignment questions, but your grade won't change after the due date. So let's go ahead and review some of the Chapter 1 topics. There's some kind of weird ones in here, so we'll try to go over them. Let's see. So some of the ones that let me go over the hardest one that I think, this distinguishing accuracy and precision. And so what we're looking at is first we have somebody's done 4 measurements and then somebody else has done a correct measurement for some reason and the true value is 42 meters per second. And then we have these other values that other groups have gotten. So we have to decide which is most accurate and which is most precise. So most accurate is going to be the number that is closest to this true value. So this is like a subtraction problem. So which one of these groups got closest to 42? So that's pretty easy. So we look through, we have 41, 43, 44, 41. So let's see. We have 41 is only 1 away from 42. Well, 43 is only 1 away from 42. 44 is 2 away from 42. And then we have this. This is between 41.7 and 41.9. 41.9. So this number we have to look in the middle. So the number right in between 41.7 and 41.9 is 41.2. So let's write this one out. This one is trickier than some of the ones I've done. Okay, so we've got 41, and what I like to do here is write them all in the same style. So this is 41 with a decimal. So again, we're going to have to look at significant figures here. So the first uncertainty is in this ones place. So this is 41 meters per second plus or minus 1. So I'm going to write them all like this. This one's already written like that, 43.0. So our uncertainty is in the tenths place, 43.0 plus or minus 0.5. That's where our uncertainty is. And then we also have 44.0 plus or minus 0.5%. So what I'm going to do is I'm going to convert this to a number instead of a percentage. So I need to figure out what is 0.5% of 44. So I'm going to multiply it by this percentage. And then it's a percentage, so I need to convert it to a decimal. So 1, 2. So I need to multiply that by 44. And I'm going to use the ALEKS calculator. The ALEKS calculator is pretty handy sometimes. So let's see if we can pull up. There it is. So we got 44 times 0.005. So that's 44 plus or minus 0.22. Okay, and then the last one, it says it's between 41.7 and 41.9. So I just have to think about what the number is in between those. So you could subtract them and then divide by 2. Or we can think about this. It's going to be 48 and then plus or minus 0.1. So if I add 1 to this number, I'll get to the top number, or excuse me, 0.1. If I subtract 0.1 from 41.8, I'll get to the 41.7. So I can write that 41.7 and 41.9. So subtract 0.1, I get to this number. Add 0.1, I get to this number. So this is the number that's in between. So this is the number that we are looking at. Okay, so then we just have to decide which of these is closest to 42. Well, this one is 1 away. This one is 1 away. This one is 2 away. Subtract 2, get to 42. And this one is subtract or add 0.2. So this is closest. So this number is the most accurate measurement. Accurate is closest to. To the true value. Okay, and then the next one is precise. How do we spell precise? Precise. Oops. We got it. Okay, precise is smallest error. So for this one, I'm going to look at this window. So this, what I really want to know is which one has the smallest percent error. So I'm going to take this plus or minus, so this divided by 41. So I'll do that in the ALEKS calculator. Oops. 1 divided by 41, and then times by 100 to get a percent, or move the decimal twice to the right. So this one has a 2% error. This one we'll do 0.5 divided by 43 times by 100 to get our percent error. So we're comparing percents. This is a 1.2% error. And then let's see. We need, this one already has our percentage for us. This is 0.5%. And then this one here, plus or minus 0.1. We're looking at our error bar. So 0.1 divided by 41.8 times by 100. That gives us 0.2% error. So this one has the smallest error. So it is the most precise because it has the smallest percent error. So let's check that. Make sure I'm doing it right. Okay, let's do another one like this. These ones in the past have been the hardest for people to move past this topic. So let me clear my board really quick and we will go over another one. Maybe we should leave our note there. So again, for this one, I'm going to write down the numbers all the same way. So we have this first number, 3.10 plus or minus 1%. Well, I don't want the percent. I want to know what 1% is. So I'm going to do 3.1 times by, and then 1%. We move the decimal 1, 2 to get our decimal. So I'm going to do 3.1 times 0.01. So plus or minus 0.031. So that's our first group. Our next group has 2.7. So if there's nothing there, then we're going to assume that our error is in the last digit. So 2.7 plus or minus 0.1. So that's where our error is coming from, the last significant digit. C, our group Oh, this one's written already how we want it. 2.30 plus or minus 0.02. And then the last one, the last group says between 2.3 and 2.7. So we can do this, we can think through it, or we can do it like this. We can do 2.7 minus 2.3. Figure out how big of a gap that is. So it's a 0.4 gap. We can split that in two. And then add that to the bottom number. So 2.3 plus 0.2 is 2.5. So that's our middle number. So 2.5 is right between 2.3 and 2.7. So 2.5, and then if we add 0.2, we'll get to the top number. If we subtract 0.2, we'll get to the bottom number. So now we have these all written in the same style. And then we need the most accurate. So again, the most accurate is the one that's going to be closest to the true value. And here they say our true value is 2.70. So we're going to look through these, and this one seems pretty straightforward. 2.7 is the closest to 2.7. So that's going to be the most accurate. The most closest to the true value is the most accurate. And then most precise, we need to figure out the error. So percent error. So we're going to take this error bar and divide it by the value that we measured. So I'm going to do that on my ALEKS calculator. You can use whatever calculator you want for this class. I guess besides on the test, you can't use your phone calculator. So my error bar divided by that number. And then remember, we want it as a percent just to compare all of them the same way. Oh, and it's 1%. And I didn't need to do that because it's already there. This one told us the error in percent. So that's embarrassing. We didn't need to do that. Okay, the next one is 0.1. 0.1. And our error was 2.7. And then we multiply by 100 to get our percent. So that is a 3% error. The next one is 0.02 divided by our measurement, 2.3, times by 100. And that is an error of 0.87. I'm not being very careful with my significant figures on the error. And then between 2.3 and 2.7, so this is our measurement, 2.5, and then this is the error associated with that measurement. So 0.2, divided by 2.5 times by 100, we get 8%. Okay, so our smallest error is the most precise measurement. Smallest error looks like it's C. And then let's check. And that's right. Okay, so there's always an explanation in ALEKS. So if you're getting stuck, you can also look there. You can also email me and I can go through, if you have a particular problem that you're getting stuck on, we can do that one. Sometimes you can do this without doing all the math. For me, the easiest way to get through this problem is to make sure that I'm just going through, and it's a little bit tedious, but that's how I found that I'm most consistent at getting this question correct. The other way would be looking at like, oh, this is a pretty small number. This one is also a really small number, so this one's probably going to be the most precise, and doing it that way. So try this one for yourself, see what is going to work. If you can't get it by just looking at it, then I would go through and do this tedious math and compare the values that way.